Let's try problem 8.5. You're carrying a 3.6 meter long, 25 kilogram pole to a construction site when you decide to stop for a rest. You place one end of the pole on a fence post and hold the other end of the pole 35 centimeters from its tip. How much force must you exert to keep the pole motionless in horizontal position? Okay, the first thing is always just to draw a picture. So let's just say this is my fence post right here, and I have a pole. Let's just say this is me right here, and I have to hold this pole. So the first thing to do is just to figure out what forces are going to be on the pole, right? So there's going to be a force from the weight of the pole, which always occurs right in the center. And that's going to just be its weight, right? There's also going to be a force from me pushing it up. And so this weight's going to try to rotate it this way, right? It's going to try to rotate it around that way. And me pushing it up is going to try to rotate it in this direction. And so we're trying to figure out how hard I have to push this pole. And so this just becomes a torque problem. We want all the torques to be zero, right? Because that means this won't be rotating at all. And so the first torque is going to just be the weight. And so it's going to be the mass of the pole times gravity times the distance to the middle of the pole. So we're told that's 3.6 meters long. So let's just call it, so 1/2 of 3.6 is going to be 1.8 meters. And then this weight is going to rotate it in the clockwise direction, right? So if I'm rotating clockwise, right, it's going to be a negative torque. So this is negative. And it's at a 90-degree angle, so we don't have to work it. So the sine of theta is just going to be -1. So we took count of that. And then plus, so I'm going to be pushing it up with some force, right? So that's what we're trying to figure out. So let's just say F. And then the distance, which is going to be 3.6 meters, but I'm holding it 35 centimeters from its tip, and 35 centimeters is just 0.35 meters, right? So the force perpendicular times 3.6 minus 0.35 is just 3.25 meters. Okay, so now in order for this not to rotate, we just I'm just going to add this term right here to both sides. And so we're left with m sub p, mass of the person, times gravity, times 1.8 meters is equal to force perpendicular times 3.25 meters. And so we just divide 3.25 meters to both sides, and we get that this force that I'm pushing up with it has to be equal to the mass of the person times gravity times 1.8 meters over 3.25 meters. And so this just becomes 25 kilograms, right? The mass of the pole, sorry, I think I was saying person. This is mass of the pole. So 25 kilograms times 9.8 meters per second squared times 1.8 meters over 3.25 meters. And so this comes out to, let me put this in the calculator, this comes out to 140 newtons. And so I have to apply 140 newtons to make sure that this pole doesn't try to rotate around this way. And so that's problem 8.5.